SEM 105. Here we're going to view ASCII, and you're eventually going to have to read some numbers and add them up. So we'll just start with this greet program, which is one you've seen before, just to give you an example to start working from. So here is greet. Let me make this fit on the screen better. All right. And probably down a bit would be good. All right, so let's cat greet.c. All right, what's the deal? Oh, greet.asm, of course, not C. Okay. All right, so here we are. I guess I got to make it even wider. Even wider. All right, there. All right, so you have a text section. Is the only section we have here. It's going to start, and here we'll have another section later, but here's the text section. So it moves the length of the prompt here, moves a pointer to the prompt here, uses device 1 and writes. So this is going to write a message, len prompt. If you look in the data section, you'll find prompt is here. What is your name? Carriage return line feed. And here's the length prompt, which is going to take this location minus that to give me the length of it. So that's going to print this message. Then you see another message called hello. And then you see a message called your name, which is just 10 empty spaces. So that's an empty placeholder for the name. So it's going to print the prompt saying, what is your name? Then it's going to read a name from the user up to a limit of 10 characters. And then it's going to write out hello. And then it's going to write out, it's going to move the length of your name, hello, add edx6, add edx length name, okay. So it's going to start with the address of hello, and then move forward 6 characters, and this is going to point to the last letter of the name. Now it's going to write the letters of the name one by one into that place, space reserved for it. It's got a loop here, but the next character is going to loop to the next character. Loop will go till ECX goes down to 0. So here's the length of the name. So it's going to do that many write locations to write the characters of the name one by one into that location. Then it's going to do a syswrite from length hello. So you see the way this works is you have hello, and there's all this space here. So it reads your name into here, your name, and then it copies it from the end to the start into the corresponding locations here. So this string will now be hello, comma, your name, and then it prints it out. That's the plan. So if I run it, hello. All right, what's going on here? Oh, it's greet, okay. All right, now give it a name of Sam. It says hello, Sam. And if I try to give it a long name, it works. It just reads the first 10 characters and prints them out, and the extra characters are just waiting in the buffer, and it tries to execute them as a command later, so it doesn't crash or anything. It doesn't overflow. It reads only the first 10 characters here where there's room for that. So that's an example of how to read input, process it byte by byte, and then print out the answer. And so now you have some challenges, like here, you're going to take 2-digit numbers, and you have to turn them into ASCII. So 65 is the base 10 code for capital A. And remember, we looked at this before. If you look for ASCII table here, you'll find them all over the web, and you can see if you look at decimal, 65 is a capital A, 66 is a capital B, and so on. So this 84 is going to be a T, a capital T. And you want to do that comparison. And so what you want to do is just take these characters, interpret them as base 10, and then write them into a storage location. So set aside a storage location like this with some spaces, and then just set this equal to the numerical value of this 2-digit number, which you'll have to calculate. And you can fill in byte by byte here in assembly code, turning these 2-digit numbers into single byte values, which will be printable, and then just print out the answer. And here's another way to do it. This is going to take a string of decimal numbers with commas. So you'll have to read characters, find the comma, and then evaluate up to a 3-digit number here in base 10, and then write that as a single byte on top of there. That's how you're going to do this. So it gives you practice handling bytes one by one and handling characters one by one. That's the idea here. All right, so let me stop this one. I see no questions.